So I'm not against ChatGPT. I'm not against the Google Bard. I am not against any of that. I think they have their place. Now, large language models, which you probably know is what ChatGPT and Google Bard are going to change the way we work. And I think that's totally fine. And as I was telling Francis at the beginning, I have for a long time thought the way that we teach statistics is kind of stupid. And I will tell you, I normally actually I've taught biostatistics a lot in epidemiology, but very often I teach advanced quantitative data analysis. If I only have a chance to teach one course in a year, that's what National asked me to teach. So it's multivariate methods. And when I first started teaching, I looked at all the PowerPoints and the person who taught it before, and it was all proofs, like proving why this is how, that the logistic regression, you get the log of the odds. And I emailed the dean and said, I'm not doing it. There's no use to this. We're going to go through how to do this with the computer because that's what people are going to do for their entire career. So I am all for pasting things into ChatGPT or Google Bard and getting a start. And what questions ChatGPT can answer, and this is why, as I was saying at the beginning, I know for epidemiology, which I'm teaching next month, it's going to be dramatically different than it has been in the past. I also know that there's somebody, not me, is going to be doing because I was told this, that somebody is going to be dramatically changing the biostatistics class as well. So that I could tell you all of the questions that were in epidemiology, where there were questions at the back of the book, where you could copy and paste them into ChatGPT. Here's these numbers, find the sensitivity. That's all gone. The things that ChatGPT is good for are basic definition questions. What is sensitivity? What is specificity? What is positive predictive value? To me, looking that up is no different than putting into Google. Straightforward design questions. I have two variables. One of them is binary, and my dependent variable is continuous. What statistical test should I use? That's perfectly fine. In fact, I used to recommend some websites that would prompt you with a set of questions to give you the right answer. Unfortunately, one of those is not available anymore, and the other one's got so many ads on it, it's useless. But that's perfectly fine. Application of formula questions, usually it works. Not always, and sometimes gives you the wrong answer. But those are questions that ChatGPT can usually answer well. I've been following this since the beginning. It's getting better and better. They got some really smart people working on it. So those are things that you could answer. And so does this mean that everything can be done with ChatGPT? And this is me just laughing, ha, 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 ha. But no, it cannot. And no, we're all going to have jobs. But let's go through some questions that ChatGPT just didn't answer. So I pulled some out of the textbook. So this one, a recent study reported the prevalence of hyperlipidemia, which is total cholesterol, basically high cholesterol, is 30% in children 2 to 6. If 12 children are analyzed, what's the probability at least 3 are hyperlipidemic? So I tried this twice with ChatGPT, and both times it gave me the equation to find the answer, and one time it gave me the Python code to find the answer. Now, do you know how useless you are to me as an employee if I ask you a question and you give me the equation for the answer? Because I could look that stuff up myself. The Python code, I could run it, but that's what I have you for. Not you personally, but that's why I have minions, right? So I did put it into StatTruck, that link I gave you, and it did give me the correct answer. Is it cheating to use that any more than ChatGPT? Of course not. So one of the problems next week, or problems discussion questions, is for you to go out and contribute to the body of the knowledge of this cohort you're in and give us some resource like this that you find. Because one of the things that I find on the internet, and it's true for anybody who teaches anything, there's so much stuff out there that the bigger challenge is going through the stuff that's garbage and finding things that are good. So anyway, this did give me the correct answer. ChatGPT did not. I tried twice. Again, here's another one where I pasted in a table and said the following data are on parents and children, what's the probability that one or both parents are hyperlipidemic? And again, ChatGPT gave me Python code, but not the correct answer. And Google Bard did give me the answer, which is 0.60, again, if you're interested. So one of the problems with ChatGPT is sometimes it just gives you the code or the equations and not the actual answer. And of course, if you're going back to your boss, your commanding officer, your client with that, that's pretty useless. Now, if you know Python, you want to run it, that's good. And like I said, using ChatGPT, Google Bard, other large language models for that, and now you have gotten a tip that if you don't find it in ChatGPT, try Google Bard, because it often will actually run the code for you. That, in my opinion, isn't cheating any more than using SAS or a statistical calculator. And like I said earlier, when I was in grad school, some people told me I was cheating because instead of doing it with a pencil and paper, I wrote programs to it. But since all of these answers now you can get by copying and pasting the questions and not really knowing anything at all, that means that in the very near future, and I can say for epidemiology as of next month, like in a week, your exams and courses are going to change dramatically. And that's not a bad thing. Like I said at the beginning, I used to say that I would never hire anybody right out of grad school because they didn't know anything. They would go and they would come and tell me how to prove the central limit theorem or the equation for computing a binomial probability. And what use is that to me? You know, I run a company where we actually analyze data to answer questions for people. So somebody in Mastodon said this, and it's true that if you've heard people saying that ChatGPT is going to be like everybody having your own junior programmer. And he said, yeah, ChatGPT is exactly like having your own junior programmer. You need to give them precise instructions and check every single thing they do, and often it's wrong. As Francis was saying earlier, that you have to get exact instructions, and sometimes it says, and I don't understand. And then sometimes, and you need to know the questions to ask. So let's go through an example. We're going to go through a couple of examples of real life examples where ChatGPT gave answers, where they were kind of off. And these are the kind of questions you are going to be getting in the future, including the final exam, which is the real near future. So here's one thing I pasted in. If I suspected Agent Orange was a factor in higher incidence of cancer in marines, what would be my null hypothesis? And what would be my research hypothesis? What statistical design would I use to test it? And how would I collect my data? So the first thing it said is there's no relationship between exposure to Agent Orange and the incidence of cancer in marines. That is no problem at all with that null hypothesis. The research hypothesis, a lot of what I do as a statistician, I know at the beginning, some of you said you were interested in careers in public health. The funny thing about biostatistics and epidemiology is 5 years ago, this was, to other people's mind anyway, a relatively boring application of statistics to health. Okay. And then COVID happened. And all of these people were just throwing the most insane accusations at the CDC, and there were all these debates about it. And even before that, my early career, I worked with an advisor whose main source of a lot of money was testifying on behalf of, in malpractice cases, where some child was injured at birth and there were major complications. And so my point is, whether you're testifying to Congress, you're in a court case, you're standing up in front of the public, if you looked at all the news these days, there's a lot of people who have a lot of opinions. So if I come up with this research hypothesis that exposure to Agent Orange is associated with a higher incidence of cancer in Marines, that is what in Chapter 7 is referred to as a one-tailed test. And if I'm the manufacturer of Agent Orange, I'm going to jump right up and challenge that and say, how do you know that? How do you know it's a one-tailed test? Your hedging the bets. Remember how we talked last time on Monday about how if you use a one-tailed test as opposed to a two-tailed test, you're putting all the probability in the right end of the curve? I'm going to be jumping up and saying, how do you know that's true? Maybe being exposed to this reduced your risk of cancer because it killed other things, or because you weren't smoking as much, because you couldn't because you were around it, or whatever reason. So I would really question that research hypothesis. Now, there's statistical design. To test these hypotheses, you can use a retrospective cohort study design, identify a group of Marines exposed to Agent Orange, a comparison group who weren't exposed. And then you track their medical records over time to determine the incidence of cancer in each group. And that is not a bad idea. That is a good suggestion. So yeah, this is a good idea if you can get access to the data. Maybe if you work for the VA, or maybe if you have somebody as a sponsor, but just like I said, if you think it's easy to get that data, you just try it. So if you can get access to data, and if you can get funding for the study, because you talk about a cohort study, generally a lot of money, you could track their medical records over time. You could do it retrospectively to determine the incidence of cancer. And if the exposure is accurate, so those are the kind of questions that I would ask. If you come to my office and say, this is what we're going to do, and I'm going to say, well, a few other things. So we'll get them. We're going to select a group of Marines who are exposed. So this is, again, ChatGPT. Select a group of Marines who are exposed to Agent Orange during their service. Comparable group of Marines who are not exposed, control group. Good. These groups should be matched as closely as possible in terms of age, gender, military service period, and other relevant factors. So what are the problems that you see coming up here? The first one, what are those other relevant factors? Now, you all are probably too young to remember the long period when cigarette companies were denying there was a link with cancer. And they would come up with every possible excuse that it had to do with other factors, that people in higher risk occupations were more likely to smoke, and people from earlier periods of history were more likely to smoke. And so those other factors, what exactly is that going to be? The other question I'm going to ask, how are you deciding if they've been exposed to Agent Orange? Is it where they were stationed? Is it self-report? Because as we talked about at the very beginning, all these chapters come together, right? About self-report bias, that people who have cancer are more likely to bring up the fact that they were exposed to Agent Orange. I have a very dear friend who has prostate cancer, and he was stationed at Camp Lejeune. And after he developed cancer, he said, oh, well, I was exposed to Agent Orange. And I'm not believe him, but he had never brought it up, thought about it until then. So maybe those people who don't have cancer are less likely to remember it. So that was kind of in the very beginning of the textbook. Is there any way to get duration of exposure? Because if you were exposed every day for 2 years, that's probably very different than you were exposed one day. How much of the toxin they were exposed to. So these are things that you're going to be asked in the future. All right, here's what ChatGPT tells you. Now, you as a human, and you as somebody who's read all this stuff and come to all these online sessions, what do you think? Then the next thing that ChatGPT says is to calculate and compare basic statistics for both groups, like the mean age, gender distribution, and other relevant demographics. And that's a good idea too. The one thing it doesn't mention is to look out for outliers. And if you remember chapter 4, that was even a question about what happens when you have an outlier. You have a larger standard deviation. So if you have people, so one of the things that you're controlling for is age, for example. If you have a few people who are very, very old and also in the Agent Orange group, and they're more likely to get cancer, that small group, maybe that's going to impact your results. So Do you want to look at your distribution, specifically look at outliers? So we talked a little bit about a hypothetical example. So we're going to look at an actual example with real data. And I pasted this in ChatGPT too. How can I analyze data to tell if there are racial differences in death of COVID patients? And this is the sort of thing that for real, we were all doing, like statisticians, epidemiologists were all doing over the last 2 years, running as fast as they could, trying to figure out what's going on with this pandemic, who's getting it, who's dying of it, what are the comorbid conditions that make you more at risk. And so one of the concerns is if there were racial differences in deaths of patients. So I put that in ChatGPT, and it said, gather a data set containing relevant information about COVID-19 patients, including the race, ethnicity, and whether they survived or died. Got it. I did that. Didn't tell me where the data was, but that's okay, because I'm a person, and I went and found it. And I will show you about that in a minute, too. Ensure the data is clean and accurate, handling missing values appropriately. Great. You know, I have a daughter who ran track in college and high school, and she said to me, and I was at one of her races, and she said, Mom, do not be like some people's moms and yell, run faster, Maria, because she said, I'm in a race, and if I could be running faster, I would be doing it. So this, ensure the data is clean and accurate and handle missing values appropriately, is kind of like saying run faster to somebody in a race. I mean, it's correct, but not helpful. All right, next it says perform chi-square Fisher's exact test for small sample sizes to determine if there's statistically significant difference in death rates. That's a good idea. Now, who is going to do this for me? And this is, again, why I always said I would never hire anybody right out of graduate school, because they all get these perfect little already cleaned up data sets at the back of the textbook, and the data are already put in a table for you, and almost none of my clients come to me like that. They say, we've collected these data and we don't know what to do with them. Or we're being accused of being biased against Native Americans or whoever, and here's all our data for the last 10 years. Can you come and testify on our behalf? Or, so anyway, somebody needs to do this. And I'm going through this because, as I said, when I interview people, or sometimes when we have interns, there's our company's headquartered in Minnesota, so this program, SciTech Minnesota, will sometimes get paid because we don't believe in unpaid interns. We get paid interns, and they will tell me, well, you should do this. You should perform a chi-square. You should. Yeah, you should do that because I'm over here doing something else. So I went and I did this chi-square, and I also fixed the missing data and did all that stuff. So here's my results. This is race. This is the percent of each race that did not die. This percent did. So 5.84 of Asian Americans, 3.92 if you're Black, 8.09 if you're Hispanic. I guess I'm in the red zone. 5.65 if you're Native American, 4.58 if you're white. So those are the percentages of people who died, and we had 123,429 people who died, and almost 2.5 million people who didn't. So it's a fairly large sample size. And the first question people ask, which is usually not the most important one, but I'm going to go over it because there's a whole chapter on it, chapter 7, and it was long and boring and difficult, so I don't want you to feel like you did that for nothing. Talks about statistical significance and hypothesis testing. So your null hypothesis, your null hypothesis would be there is no difference in death rate by race. And over here, you can see that you had a chi-square value of 7,186. And last time I said that chi-square is the observed minus the expected squared divided by the expected. And if there's no difference between the two, if you get exactly what you would expect, if there was no relationship among the variables, you'd get a chi-square of 0. Now, you don't need a PhD in statistics to know that 7,000 is a long way from 0. So you look over there, and the probability is 0.00 0.01. So, test question, would you accept or reject the null hypothesis? If the probability is less than 0.05, that means the chance of you getting a relationship this high by chance would occur 5 times out of 100. This says, this is actually as low as SAS goes, it doesn't show 0. This says a relationship this large would occur 1 time out of 10,000. So it's probably not occurred by chance, and you would reject the null hypothesis. So you would say, yes, there is in fact evidence for a relationship between death rate and age. I'm sorry, not an age, and ethnicity, race, ethnicity. So then, here's the things that ChatGPT doesn't do for you. What else should you ask? Because I'm actually super happy that now people can take and copy and paste these answers into questions in ChatGPT and get the answer. Because never was that the kind of stuff that I needed people that I hired for my company to do. We never had any neat little problems like that. We had things where somebody was saying there was a difference in death rate by race, and we, by God, ought to be doing something for the reservation. And somebody else saying, no, there wasn't. So 2 things. And this is where someone on one of the answers to some of the questions had put that they didn't think they could ethically answer it because they had no knowledge of this particular field of medicine. And the truth is, you are usually not working alone on a project like this, right? You're working with people who, like, I know a lot about healthcare costs and length of stay and different diagnoses, but if you asked me to look at a slide of something on a microscope and tell you if this was one kind of virus or another, couldn't do it. So you're usually working with a group of people who know something about that specific field. So in this case, if you know something about COVID, you would know that if you're white, you're less likely to have gotten the COVID vaccines initially, and you're less likely to have gotten the boosters. And that for the Native American community, initially it was darn near 100%. So it may be that if you looked at these statistics by year of diagnosis before the vaccines came out, you would find much greater differences, because some of the differences might have been ameliorated by the fact that some communities got higher rates of vaccines than the other. So one thing I might want to look at is by year of diagnosis and see, did this discrepancy change after vaccines became available? Another thing is, we can already see right over here that the death rate's lower for the white population, but shouldn't it be higher? Because, and again, this has to do with maybe you knowing something about the demographics of the United States. The Hispanic population in the U.S. is significantly lower in age than the non-Hispanic population. The Native American population is significantly lower in age. So this is kind of edging into the next chapter next week. But once you put in age, maybe these discrepancies would be even greater. So those are the kinds of questions that ChatGPT is not going to ask you or even suggest that you look into. Now, maybe it will eventually, but not yet. So since I did not have any little genies stopping in here to analyze this data for me, we're going to do it and show how you could do it.